Yes, I do.
Okay, so I find
Quadrilaterals too.
I'm gonna send this to you at the end. I'll refer back to it. This is really important to understand, and I would organize it slightly differently. But if we go left here, this means that there are two sets of parallel lines. All of these have two sets of parallel lines, and then you know that like this side is congruent to this side, and this side is congruent to this side, and consecutive angles add up to 180, and there's a bunch of things about parallelograms. Those all apply vertically, like everything that I just said applies down here. Okay, these have like additional properties to them. All right.
Yeah.
And like a rectangle, for example, it has 90 degrees. Okay, but the sides are not all the same. Rhombus, all the sides are the same, but the angle isn't 90 degrees. A square has all sides the same and 90 degrees. So let me try to explain this here. The properties of quadrilaterals. Parallel sides are parallel. So this is parallel to this, the top is parallel to the bottom, opposite sides are congruent. We said that opposite angles are congruent. The diagonals bisect each other. I didn't say that, and there's consecutive angles are supplementary. I did say that.
Yeah.
Now rectangles, here's what it says here. It says have all the properties of a parallelogram plus a couple. Okay.
Yeah.
And in like a rhombus down here, it'll say all the properties of a parallelogram and a couple other things. Actually, quite a few things. Square, all the properties of a rectangle and a rhombus and one other thing.
Okay.
So what you have to like become very comfortable with is like knowing the big one, parallelogram in this case, and then like how each of these, you know, further they become more specific. And then there's other things that we're gonna say that I'm gonna try and say right now correctly. Every square is a rectangle, but not every rectangle is a square.
Yeah.
Okay, so that
I might hear that all the time.
And so, but you can say every rectangle is a parallelogram. Sometimes that's easier to understand. Every rectangle is a parallelogram, but not every parallelogram is a rectangle. Okay, so the other thing here, and I really like these charts here. The next, I actually want to go down to this right-hand side. So there's two sets of parallel sides over here. Trapezoids have one set of parallel sides, top and bottom usually, or if they're rotated, it could be top and bottom, but one set of parallel sides, one set of parallel sides, one set of parallel sides. Kites have no sets of parallel sides. So the quadrilateral is divided based on the number of parallel sides. It never says that, but it should. It should definitely say that here. This one also has a these boxes match up with the images up here.
Yeah.
So I really like this one too, although it's not as complete as this one, which is why they're both there. Now, so instead of doing question you've got this first page of your PDF is like fill in the blank.
Yeah.
I think for you, you're good enough student that you should look at those diagrams I send you and then, you know, put a yes or no basically in these.
Yeah.
And it's the kind of thing you actually might want to start with like parallelogram, trapezoid, and kite first, or start with parallelogram and then move to rectangle and rhombus and then to square.
Yeah.
Like you want to follow the flow of this picture here. Like do them in this sort of order.
Okay.
That's a recommendation. I would love to move to question 1 if you would like to move to question 1.
Sounds great.
Okay. All right, so I'm going to do a new share and you're going to see my workspace screen here and new share, and you're going to look at the notes for today. Okay, the student says that diagonals of all parallelograms bisect the angles. Is this true? Okay, so if something is true, you have to prove it. True means it's a proof.
Yeah.
It's usually hard. Or if it's sometimes true, that's fine. That's easier than a proof, but sometimes means that you have to find a works and then a doesn't work.
Yeah.
Okay. Now the key here is that you're looking at parallelograms. There's three types. There's a I'm sorry. If we go back to that image, there's the parallelogram,
Mm-hmm.
and then there's the rectangle, and then there's the rhombus, which is like a pushed over square, and then there's the square itself.
A deformed square.
A deformed square. So can you find one that doesn't work?
I think it's the rectangle.
Okay, so the idea is that the doesn't bisect the angle. So if we look at a rectangle here, and I draw it a little nicer, sometimes we can see it visually. We know that this is 90 degrees, but this could be 30 and this could be 60, and that's totally reasonable.
Yeah.
So there's your example for when it doesn't work. What's an example of when it does work?
It's a square.
Square. So that's a sometimes.
Okay. Let me get this down.
What's critical though is that you understand that for it to always be true, it's a proof. If it's never true, you're kind of taking you're gambling a little bit that there is no counterexample that you haven't thought of.
Okay.
Is it okay if we move to B, or is
Yeah.
there more questions than that? This is nice that they've actually drawn the figure for you. That's sometimes not the case. It's a find the perimeter of the triangle PMN. So I'm going to actually just separate it out. That's a technique that's usually pretty useful to do. PMN. I don't know if it's actually helpful in this one, but we'll see if it is. Measure of angle N. Okay, so if it's an isosceles trapezoid, that means that this angle is congruent to that angle. It comes from the fact that if you were to extend these, it's an isosceles triangle that's been cut off at the top.
Yeah.
Okay, so it says LM. So that means that LM and PM are congruent. So these two are congruent. So you could use that to solve for X at some point. We'll see if that's useful. It also means that MP and NL are congruent. So these are congruent as well. So that means you could solve for Y because you'll have X. I know that because I'm referring back to I'm referring back to the properties that are in that PDF that you'll have at some point.
Okay.
So have you solved for X? Have you solved for Y?
Okay.
If you haven't, I'll give you a moment to find that.
Yeah. Okay. Wait, I'm a little confused. I didn't understand how we're gonna solve for. Oh, do we just have to put one of those equations equal to what it is?
Yes, they're both.
Okay, we have to do.
Both...
Wait. Yeah, this makes no sense to me.
You're setting 1/2 X minus 1/8 equal to 1/3 X plus 1. That's solving for X. So I would.
Okay. I thought we had to put it like I thought we had to compare it to something like 1/2 X minus 1/8 equals 123 degrees or something along those lines.
So sometimes you do that, but most of the time it's either equal or adds up to like 180.
Okay. Okay. Okay, I got my answer.
What's x? What's the value of x?
It's like 54/8, or hold on, let me reduce it.
This one is a little bit odd.
27/4.
Yeah, I'm gonna multiply everything by 24 here, because that's the best one for 2, 8, and 3. So that gives you 12x minus 3 equals 8x plus 24. If I subtract that, I get 4x equals 27. So x equals 27/4.
Yeah, that's what I got.
Okay, great. You're going to do the same thing now for ln and mn, because they are congruent. The diagonals are congruent. You would know this if you read the properties. You now have the value of x. You're going to use that to find y.
Okay. At 77/3 is y.
Okay, it's very possible. 81/4, 77/4. It's 77/12.
So what I do is I multiplied 3 times 27 like over 4 minus 1 is 3y, and then you get 81/4 minus 1. So you get 77/4.
77/4, and then you got to divide that by 3, which is the same as multiplying by a third.
All right.
Your instructor is doing a good job here of taking what's really a simple like equality congruence statement and saying, okay, here's some hard algebra with fractions and stuff.
Yeah, that's what my honors geometry is just basic geometry with algebra. Okay, hold on, let me finish this off then. Okay, then multiply by 1/3. 77/12 is y. Okay. All right, I have that down.
Okay, so I mean, we've kind of diverged from what we're actually trying to do here. It says find the perimeter. So the reason you found x and the reason you found y was so that you could find this angle and this angle right here, and then mn. And you could find mn. I may have led you slightly astray here. I got my ln, mn. Huh. You know what? I led you a little bit astray. I didn't. These are not diagonals here. ln is equal to mp. So that 3 times x minus 1 is here, and then that I did that. Did I really do that twice? lm p. I'm sorry here. I've made a few mistakes, a few very careless mistakes. We have to redo a bunch of this. The best thing will be to actually just start again, fresh.
Okay,
let me grab this picture again. This is totally my fault. Okay, LM is here, and PM is this diagonal. Great. LN is the other diagonal. So it's these two that are congruent. They're the diagonals.
Okay.
those are the two you said equal to each other. 1/3 x plus 1 equals 3x minus 1. I think when you solve this, you'll get something a little bit nicer than what we got before.
Okay. I'm gonna finish erasing this stuff.
So if you clear the fraction, multiply everything by 3, you get x plus 3 equals 9x minus 1. You end up getting 4 equals 8x. You end up getting x equals 1/2, which is, I mean, it's not great, but it's...
Multiply everything by 3 and we get x plus 3 equals 9x minus 1.
There's a 3. There's 9x minus 3.
9x minus 3, yes.
So you actually get 3/4.
So
you just check that. Yeah, that does work. Okay, great. The thing that we're trying to find, the PMN.
you get 3/4 equals x.
Yes.
Okay.
The reason we do all that, we need P to M. P to M is the 1/3 x plus 1. Great. LM is the 1/2 x minus 1/8. It's the same as PM. So we have that. We can put 3/4 back in each of these. We will do that. To get MN though, it's 3y. Well, we need y, which we don't have yet. So we'll. All right. So we're almost there. But you've got x. You can put those values in. Fine. We need to do something with the angles here. MLP, M to L to P. That's this angle here. PNL. It's that angle there. That's not especially useful. M and L. That's not especially useful either. Okay. So because it's isosceles, and I actually probably should draw this without all the other lines in there. Because it's isosceles, this angle is congruent to this angle.
Okay.
So if MLP, if this is 120, that means this is 120 as well.
Okay.
The whole sum has to add up to 360. Because they're consecutive angles, this one's 60 and this one's 60, 180 gets you there. Great. PNL is this one. That's PNL. And then MNL is this other one.
Okay.
So these two together make up this.
Okay.
So that means it's 2y squared plus y plus 2y plus 58. That's those two angles. They have to equal 60.
Okay. So I see what you're saying is I need to solve for y.
Yes.
Okay.
And there might be two y's because it's a quadratic here. So
yeah, there is.
2y squared plus 3y minus 2 equals 0.
Y is 1 plus 2. So y is 1/2 and y is -2. Okay. Y is 1/2 and -2.
It's one or the other, or it could be both. But the thing is you have to now, like, what your instructor maybe hasn't explained, but I want to explain it now, is that what you just solved is a quadratic that has nothing to do with the problem itself. The quadratic might have two solutions, but your problem may not utilize both of them because, for example, up here 3y, well, you can't put in -2. I mean, you can, but the length isn't negative.
Yeah.
So you have to keep that in mind. You're like, that's 1/2, and your x value is 3/4.
Okay.
So the last step is to put those values in here to get the lengths.
Okay.
So I know you can do that. let me draw it over here. I'll give you the final answer over here. MPN. So that's 3/2, 3/4 times that. This is 5/4, and then that's 3/8, 1/8, 2/8. So this is a fourth. Great. And it wants the perimeter. Great.
Yeah.
So the perimeter is 5/4 plus 1/4 plus 3/2, which actually ends up being a nice number. Ends up equaling 3.
Okay. Let me get that last part down.
We have another part to find an angle or something in here. So we'll angle N, which we actually already found.
Okay, hold on. So let's redraw this triangle. Okay, and then
We found angle N. Angle N is 60 degrees.
okay.
We found that from the whole, like, if that's 120, that's 120. So those two must also be the same.
Plus 3/2 equals P.
Yeah.
So 3 equals P.
Yep.
Sorry if you can hear my family screaming.
It's okay. Boy, that one took way longer than I thought it would. But hopefully the next here go much faster.
I don't know. My problems usually take quite a bit of time.
In a square math, just a reminder, I am sending this to you as a PDF and the video. It's the time on that's much shorter now. So it says in square math, AH and MT are diagonals. So I don't actually like starting with that kind of information, but that's what we will do. So let's go AH. That's diagonal, and MT are diagonals. So that's MT, MATH. The measure of angle MAH, and it's important that you get the sketch correct. M to A to H, this one right here, is x squared plus x plus 45. Okay.
Okay.
You have to realize that this angle is also 45 degrees because it's a right angle and because the diagonals bisect the angle in a square.
Okay.
So that means that this other side is also equal to 45 degrees. So you could say x squared plus x plus 45. There's a lot of ways you could do it. You could say these two angles add together to be 90, or you can say that, let's do it that way, plus 45 equals 90. And then you're solving for x. So you end up getting x squared plus x equals
45.
Well, these add up to 90, and then you subtract, it ends up equaling 0. So you get x times x plus 1 equals 0. So x either equals 0 or -1.
How is that even possible?
Well, again, like what's not made clear is like it's like you're solving a problem on another planet, and sometimes the results from that planet work on Earth, but not always. This time they work.
They work. So x and
A lot of the challenge in these questions, especially from your instructor, is the fact that you do have to draw the picture correctly. So let me, I can't really reuse that picture.
Oh, I don't think we finished that problem.
What is the measure of angle ATM?
Yeah.
ATM, it's 45.
Okay.
They're all 45 in a square.
Okay.
All right, in square MATH, the diagonals AH and MT intersect in point D. So we have this, we want to reuse the picture MATH. They intersect at a point D. Great. If AD measures 1/2 x minus 5 and MT, the whole thing here, so that's usually hard to do. This whole thing is 3/5 x minus 2. What you're supposed to realize is that the diagonals are congruent in a square. Diagonals are congruent. Since they're congruent, well, A to D is half of M to T. So that you could double this 2 times this 1/2 x minus 5 is going to equal this 3/5 x minus 2.
All right.
Because that's the whole thing. So that's nice here because when you throw it in, you get x minus 10 equals 3/5 x minus 2. You could clear the fraction. You could also just say, okay, this is 5x over 5, which is 1, still works. Because when you subtract the 3/5, you get 2/5 x equals 8. And then when you multiply by 5/2 on both sides, you get x equals 20.
Yeah, that makes no sense to me. Where did you get the 5x over 5 from?
I want to match the denominator here. It's an advanced technique, but it just saves you time. You always want to make 1 always becomes the same number over the same number. Like if I asked you to do like 1 minus 16 over 27, you want to train yourself to realize, oh, this 1 is really 27 over 27 minus 16 over 27.
Yeah. Oh, let me multiply both. Wait, hold on.
If you don't like that, I mean, you can just multiply everything by 5. It just you're gonna end up just your instructor is emphasizing the algebra, but he wants you to be able to do this fast. So you have to try to learn some of these other techniques.
Oh, I see what's happening. That makes so much sense. Two x over 5. We get x equals 20. Okay, that's what you got as well. All right.
It asked for the perimeter of the square. It actually asked for way more. So AH is the same as M to MT. So it's you can just do the 3/5. So AH equals this 3/5 times 20 minus 2. That ends up being 10.
Okay.
One of the things that it makes your class tough because like your instructor's asking this like synthesis question, do this to get your answer. You need the perimeter of this thing. You know that the diagonal is 10.
Yeah.
So you have enough information. It may not seem like it, but that's 10, that's x, that's x. And if you remember did you study 45, 45, 90 triangles yet?
No.
Okay.
I mean, like we have studied it, but like not like
Well, you know Pythagorean theorem. Pythagorean theorem is x squared plus x squared equals 10 squared.
Yeah.
That's 2x squared equals 100. X squared equals 50. And then again, this is a little bit fast, but x equals 5 squared too. The reason you need that is because your perimeter of your square is 4 times x, because it's the same all the way around. So yours is 4 times 5 squared too.
Okay, hold on, let me get this down. Because this makes 0 sense to me. How did you get? Oh, okay, that doesn't make sense. Okay, hold on. 10 squared. And then we get 2x squared equals 100. And we get x squared equals 50. And then we get x equals 2. Or 5 root 2, not 2 root 5.
In part C, it asks you what properties did you use to solve this problem. It would be best to actually go do this as the first part and say, what are the properties of a square? Because those are what you're going to use to solve it. And you can grab those from that reference that I'll send you.
Okay, so what does part C ask?
It says what properties did you use, and I wrote a few down here. I mean, it's PAG, Pythagorean theorem, 45, 45, 90 triangle, diagonals are congruent.
Okay.
Diagonals bisect each other. That's another one.
And then diagonals.
They're going to come right from that list that I'll send you, and you'll you just write them down. I mean, they're see here what the list says. Right angles, diagonals are congruent.
Okay. Let me get a new piece of paper. Okay, let me this 3A.
Are you ready to start this one?
Yes.
Okay. Rhombus. So let me quickly remind you that in a rhombus, I can't remember what you said exactly. You said it's a deformed square.
A deformed square, yeah.
Deformed square. Okay. It's got diagonals AC.
We're bullying rhombuses now.
Yeah, we got to be careful with that in today's world. So AC is a diagonal, and BD is another diagonal. I'm not going to draw that quite yet. Oh, I guess I do. So A to B to D is 30 degrees.
Mm-hmm.
And B to A to C is that thing right there, 2x squared plus 4x plus 12. Find the measure of x and the measure of angle BAD. Okay. So again, like this is one of those where you're like, maybe you don't know where to start. I can read some of the properties of a rhombus. See if any. So we're looking for something to do with angles. Would you agree with that?
Yeah.
So the first one is it says all the properties of parallelogram. So let's go back to the properties of parallelogram. First one's about sides. I don't care about sides. Opposite angles are congruent. Does that help here? Are there?
Yes.
Okay, so if that's true, like that means you've got like whole angle A and whole angle B. It's definitely needed to find BAC, but not quite yet. So how about any pair of consecutive angles or supplementary? Does that help? It doesn't, because we don't have the whole thing.
No.
What kind of triangles are made in a rhombus? Well, the diagonals are perpendicular. That means that this is a right triangle.
Right angle.
So that means that these two angles that they just gave you have to add up to 90. 2x squared plus 4x plus 12.
12 equals 60.
Yeah, I'm gonna write it all out just so you've got it, because you're really gonna move everything over to the left side. You get 2x squared plus 4x minus 48 equals 0. You can factor 2 out, you get x squared plus 2x minus 24 equals 0. You get x plus 6, x minus 4. So x could be -6 or x could be 4.
Okay.
They both work. The reason I can say that they both work is because they both produce something in this that's positive. Like it's a real angle measure in here.
Okay.
You could verify that.
Wait.
If one. You might be
Like,
concerned
how
about
does
that.
-6 work?
Well, it's 2 times -6 squared plus 4 times -6 plus 12. It's not that this individual piece can't, this individual piece could be negative, but the whole thing is going to be.
Oh, right.
And I mean, you already know it's going to be, this is 60.
Yeah.
I mean, you already said that. So great. Now we can label some other angles in this thing. So AB is parallel to DC. So this is 30 down here. That means this is 60.
My brother's stealing my charger.
It's not your charger, Zane.
Bryce, I'm on tutoring right now.
You're on what?
I'm doing tutoring right now.
Sorry.
All right, so the measure of angle BAD, a lot of ways to find it, but it ends up being these two angles added together, 30 and 60, ends up being 90. So this thing is actually no, I guess it's a square. It's weird. Okay. Angle bad is 90.
Okay.
What does it ask for next? Part B. The perimeter is 40 inches long. If the length of AC is 12 inches, the length of BD is 2x plus 4. What is the length of the diagonals? Okay, I'm just reading it out loud. We need to know something about the diagonals. They usually end up bisecting each other. That's sort of useful here. Let me, I guess I'll have to redraw it. Snip this in.
I don't know if your screen froze, but oh, never mind. Your screen didn't freeze. I was like, you can't do anything.
Yeah, sometimes I'm trying to get there. So the length of AC is 12 inches. BD. Okay. Let's go like
Should we just redraw it?
Yep.
Okay.
A, B, C, D.
Looks like this isn't a deformed square. It's a normal square.
Yep, 12, and BD is 2x plus 4. So the thing is they bisect each other. So this is 6 and this is 6. And then these are the same here as well. So that means that like this is x plus 2 and this is x plus 2 because those add up together to give you that.
Okay.
What is the length of the diagonals? So we know that the perimeter is 40 inches. That means that all three of these are the same, or all four of these are the same because it's a rhombus.
Yep.
That means they're all 10. Okay. And you already know this is a right triangle, so you can say 6 squared plus x plus 2 squared equals 10 squared.
Okay.
Go ahead and solve for this. You're going to find there's actually two answers. One of them will not be allowed, though. We'll talk about why in a moment. It's not because it's negative, but we'll talk about why.
I actually have zero idea on how I'm going to solve this.
Okay.
Oh, wait, so, no, I do.
All right.
X plus 2 squared equals 100 minus 36 minus 36 So you get x plus 2 squared equals 64. Okay, and then we take the square root of both sides. X plus 2 equals. Okay. So it's x plus 2 equals. Okay, x plus 2 is plus or minus 8. Okay. And then we can subtract 2, and we get x equals -2 plus or minus 8. Okay. So x is either negative 10. X is -10, or x is 6.
Good. Good. Excellent. Okay. Now, because the length of BD is linear, when you put in -10, 2 times -10 plus 4, this is going to end up giving you this ends up being negative. So that's why you can't have that. And you're a good math student, so I want you to understand it's not because that number is negative. It's because when you put that number back in,
Yeah.
It's
like, because the problem before we had it where there was a negative number and it did work.
right. Okay. So now that you have x as being 6, you can find the length of the diagonals. This one is it ends up being 8 plus 8. So
16.
Yeah, so AC is 12. We already knew that. BD is 16. So it said, what properties did you use to solve this problem? I mean, I said them verbally, but there's so much. The fact that it's a rhombus means that all the sides are congruent. That's for sure a property. It produces the diagonals bisect each other. That's how we found that these were equal. The diagonals are perpendicular. That help with the right triangle.
Wait, it's diagonals bisect, right?
They bisect each other, yeah.
And then also the diagonals.
Perpendicular.
Yep. Okay.
If that's all you got, this is a great place to stop. I can get the notes and the video to you shortly here.
Okay. Sounds great.
All right, Zane, good job today, and see you next time.
Thank you.
Bye now.